Welcome to Rockfect classes. In this class, I will continue infinite series. In previous video, I have discussed about what is an infinite series and convergence or divergent series. Now I am taking here one example for proving convergent and divergent series. For example, we have given in statement we have to show that geometric series sigma infinite n is to infinite n is equal to 1 r raised to power n minus 1, that is equal to 1 plus r square plus r raised to power 3 plus up to infinite. Here r is greater than 0, then we can say it is a convergent. If r is less than equal to 0, less than 1, and diverges. If r is greater than equal to 1. If r is greater than 0 and less than 1, that is convergent. Otherwise, if r is greater than equal to 1, then it is a divergent series. We have to prove it. First of all, suppose S1 that is equal to 1, S2 that is equal to 1 plus r, S3 that is equal to 1 plus r square. You can see, you can take here from this series. Sn that should be equal to 1 plus r square plus r cube plus up to r plus r raised to power n minus 1. Now I am taking three cases which is given in question. In according to case 1, if we take r is less than 1, then limit n is to infinite Sn that is equal to limit n is to infinite 1 minus r raised to power n over 1 minus r. We should be take this formula and now take limit n is to infinite 1 by 1 minus r minus limit n is to infinite r raised to power n over 1 minus r, and here 1 over 1 minus r as limit n raised to power infinite r raised to power n that is equal to 0 if we take r is less than 1. So we can say because limit n infinite, n is to infinite, s is finite. So the sequence of partial sums, that is Sn converges and hence the given series converges. Now case 2, r is greater than 1. Now take again limit n is to infinite, Sn is equal to, in this case we will write limit n is to infinite r raised to power n minus 1 over r 1 minus r minus 1. Now take the limit separately. Limit n is to infinite r raised to power n over r minus 1, or you can write it 1 minus r also. 1 minus r minus 1 over r minus 1. As r raised to power n is to infinite, when if r is greater than 1. Case 3, here we can say Sn diverges and hence the series diverges. In case 3, when we take r is equal to 1, then we consider an Sn is equal to 1 plus r square plus r cube plus up to r raised to power n minus 1. And we will take here r1, 1 raised to power 2, 1 raised to power 3, 1 raised to power n minus 1. And we will find that here 1 plus 1 plus 1 plus 1, that is equal to n, and limit n is to infinite, Sn is equal to infinite. Because here Sn diverges, so given series diverges. Now next topic I will discuss about positive term series. What is positive term series? Positive term series means when all elements of series are positive, that is known as positive term series, and it is also known as P series. Now example of P series, that is sigma infinite n equal to 1 by n raised to power p is given, and its series will be 1 by n all natural numbers, 1 raised to power p plus 2 raised to power p plus 1 by 3 raised to power p plus up to, and p is greater than 0 is called P series. P series. if and two conditions. There should be, keep in mind, two conditions. First, if p is greater than 1, then converges. Second, if p is less than equal to 1, then diverges. Now next, I am giving you example for converges and diverges. For example, we have given sigma infinite n equal to 1, 1 by n raised to power 3, that is equal to 1 raised to power 3 plus 2 raised to power 3, 1 by 3 raised to power 3. Here you can see p is greater than 0, or you can say p is greater than 1. Here p is greater than 1, so it is a converges series. But on the other side, if you have given like this series, 1 by n raised to power 1 by 2 equal to 1 by 1 by 2 plus 1 by 2 by 2 by 1 by 2 plus 1 3 raised to power 1 by 2. Here p is less than 1, so it is a divergence series. Now next points you should keep in mind: what necessary conditions for convergence. What are the necessary conditions? Necessary condition for convergence. You should keep in mind that if an infinite series, that is sigma infinite n equal to 1 un is convergent, then limit n is to infinite un is equal to 0. However, converge need not be true. Now we will take example. For example, we have given sigma infinite n is equal to 1 cos 1 by n, and we have to test convergence of this series. First of all, how to solve it? First of all, you should write un is equal to cos 1 by n. After that, taking limit both sides, n is to infinite un equal to limit n is to infinite cos 1 by n. And cos 1 by n, when we put n value, that is infinite, 1 by infinite, that is of cos value is equal to 1, that is equal to not equal to 0. So it is it is not convergent. Now I am taking one more example. For example, you have given in sigma infinite n equal to 1. Here you have taken root n over n plus 1. First step, write un is equal to in square root n over n plus 1. Now taking limit both sides n infinite, n is to infinite, un is equal to limit n is to infinite in square root n over n plus 1. Take the root n common in denominator. You will write here 1 plus 1 over square root. Root n cancel with root n. You will find 1 over in square root 1 plus 1 over root n. Now when you put the value of infinite n like this, you will find its answer that 1 by 0, you will find it 1 over 1 plus 0, 1 over 1, that is not equal to 0, and so it is not convergent. Now next topic, tests for the convergence of infinite series. You can take one more example for testing. Sigma infinite n equal to 0, 1 by log n. First of all, write un is equal to 1 over log n. Then take limit n is to infinite un. Then take limit n is to infinite 1 over log n. Here you know very well n raised to power n. Here you will very well known that log n, because log n that is less than n for n when greater than equal to 2. So 1 by log n that is greater than 1 by n for n greater than equal to 2. So on the other hand, we can say that 1 by n is less than 1 by log n for n is greater than equal to 2. Now sigma infinite n equal to 1, 1 by n is a divergent series because p is equal to 1, and thus by comparison test it is also divergent. Now I am going to discuss next topic, that is limit form test. Limit form test, in which we will take two positive term series un and vn, and taking limit both. After that we write limit n is to infinite un over vn, that should be equal to L, and where L is finite and non-zero number. And then we can say sigma infinite n is equal to 1 un, and sigma infinite n is equal to 1 vn. Both terms behave in the same manner, that is both converges or both diverges. Now I am taking one example for solving this equation. For example, you have given series 1 by 3.7 plus 1 by 4.9 plus 1 by 5 into 11 plus. Here you can see this series how to increasing n plus 1 way. Here we will take n equal to 3, and n plus 1 next number, n plus 1 next number, and this series will come by 2n plus 5 way. How? You can take here, if we take here 2 into 2 plus 5, 2 2s are 4, 4 plus 5 9, and next number 11, 2 into 3 plus 5, 2 3s are 6, 6 plus 5, that is 11. So that's why we will take first of all un, that is equal to 1 over n plus 1 and 2n plus 5 series. When we solved this equation, it will be 2n square, n multiply 2n, that is 2n square, 1 multiply 2n, that is 2n, 5 multiply n, that is 5n. You can if we take here 2, then 2 plus, sorry, here not taken n plus 1 series, n plus 2 series is taken, like this. If n is 1, n plus 2, 1 plus 2, that is equal to 3, 3 plus 2, that is next number 1 plus 2, 3, and next number, now 1 plus 3, that is 4, next number 1 plus 4, that is 5. So that's why we will take here n plus 2, 2 plus 2n square. After that 2 2s are 4, 4n, 5n plus 5 2s are 10, and 1 over 2n raised to power 2 plus 9n plus 10. This is un. Now we take, suppose Vn, that is equal to 1 over n square. Now consider un over Vn like this, that is 1 over n plus 2 n 2n plus 5 into n raised to power 2, n raised to power 2 over n plus 2. Sorry, here we write solved equation. Just a minute. Two n square plus 4n plus 10. 4 plus 5, 9n. 2n square plus 9n plus 10. After that, we will take limits on both sides. Take limit n infinite un over Vn, that is equal to limit n is to infinite n raised to power 2, 2n raised to power 2 plus 9n plus 10. Now take n square common from denominator, 2 plus 9 by n plus 10 by n square. N square cut with n square, you finally find out 2 plus, when we put infinite here, that will be equal to 0, and answer will be 1 by 2, and 1 by 2 is a finite and non-zero number. So hence we can say by limit form test, sigma infinite n equal to 1 un and sigma infinite n equal to 1 Vn. Vn behave in same manner because sigma infinite n equal to 1 Vn, that is equal to sigma infinite n equal to 1 by n square converges as p is equal to 2, that is greater than 1. So we can say sigma infinite n equal to 1 un is equal to sigma infinite n equal to 1 over n plus 2 to n plus 5 also converges. Thus we can implement limit form test. Now I am going to taking one more example for solving. Test the convergence of following series. For example, you have given 1 by 3 plus 1 by 2 into 3 raised to power 2 plus 1 by 3 into 3 raised to power 3 plus 1 by 4 into 3 raised to power 4. First of all, un is equal to 1 by n. 1 by n multiply 3 raised to power n, and if we take un plus 1, then we can say it will be n plus 1 into 3 raised to power n plus 1. Now take the limits both sides. N is to infinite, un plus 1 over un, that is equal to n into 3 raised to power n over n plus 1 into 3 raised to power n plus 1. Now taking 3 raised to power n common, from denominator you will find here n plus 1 and into 3 raised to power 1. This cut with this, n over 3 n plus 1. Now again I will take common in denominator n. You can see here will be 1 plus 1 over n. N cut with n. Now finally you have find out 1 plus 1 over infinite 1 over 3 into 1 plus 0 1 over 3. This is and this value is less than 1, and hence we can say ratio by ratio test, the given series converges. Now next method is related to Cauchy's nth root test. Nth root test. In this test, first of all, you have to let sigma infinite n equal to 1 un be a positive term series such that limit n is to infinite un raised to power 1 by n, that should be equal to L. And then you have to implement some conditions. First, sigma infinite n is equal to 1 un converges. When it will be converges? If L is less than 1. Second, sigma infinite n is equal to 1 un diverges if L is greater than 1. Test will be test fails if L is equal to 1. These three conditions you should keep in mind when you solve the questions, when you test the convergence. For example, you have given this series 1 plus 1 over 2 raised to power 2 plus 1 over 3 raised to power 3 plus 1 over 4 raised to power 4. First of all, you have to write un is equal to 1 over n raised to power n, because here you can see n raised to power n. And when after that take the limit n is to infinite, un is equal to limit n is to infinite 1 by, here we will take this method un power 1 by n. Here when you take this like this, you can see limit n is to infinite 1 over n, and n multiply 1 by n, n cut with n, that should be equal to limit n is to infinite 1 by n, and that will be equal to 0, and that is less than 1. When it is less than 1, we can say it is a converges according to this rule. Okay. Now I am taking one more questions for implementing Cauchy's test, Cauchy's root test. Either you can say Cauchy's root test. For example, you have given 2 raised to power 2 over 1 raised to power 2 minus 2 raised to 2 over 1 whole power minus 1 plus 3 raised to power 3 over 2 raised to power 3 minus 3 over 2 whole power minus 2 plus 4 raised to power 4 over 3 power 4 minus 4 by 3 whole power minus 3, and up to. First of all, how to solve it? First of all, you should write un is equal to, in square brackets, n plus 1 over n whole power n plus 1 minus n plus 1 over n whole power minus n. Means here 2 raised to power 2 means n plus 1, and here 2 means n is equal to 1, and 1 plus 1, that is you can see 1 plus 1, that is equal to 2. Okay, and it's a whole power also, n plus 1, so that's why 1 plus 1 2 raised to power, we will find out 2 raised to power 2 by this method, and 1 raised to power 2 means n only, n is equal to 1, 1 raised to power 2, that is equal to 1. When we take n equal to 2, that it will be 2 raised to power 3. Okay, so that's why we will write here this formula. Minus 2 by 1 means n plus 1 over n. N is 1, so 1 plus 1, that is 2, and n is 1. And for here we have proved that how why we take this un. Now next we will take according to this method. Now I am going to take it limit n is to infinite un raised to power by 1 by n in the form of y 1 by n. Limit n is to infinite un raised to power 1 by n equal to limit n is to infinite, we will write here n plus 1 over n whole power n plus 1 minus n plus 1 whole over n square minus 1 minus n multiply 1 by n cut with n. Now it will be equal to limit n is to infinite n plus 1 over n whole power n plus 1 minus n plus 1 over n whole power minus 1. Now limit n is to infinite, take the common n plus 1 over n whole power minus 1, take common value n plus 1 over n, here will be remain n minus 1 raised to power minus 1. Now limit n is to infinite, take n is common and 1 plus 1 by n over n, this n cut with this n minus 1 and also here 1 plus 1 by n over n cut with n power n minus 1 whole power minus 1. Now you can write it is whole power 1 by e minus 1, that should be equal to less than 1, so it is a converges and whole power is 1 by e minus 1. Now next test is RABS test. In this test we will suppose sigma infinite n equal to 1 un be a positive term series such that limit n is to infinite n in bracket un over un plus 1 minus 1 equal to L. We have to put this formula when we implement RABS test, and then implement these three conditions: sigma infinite n is equal to 1 un converges if L is greater than 1, and according to second condition sigma infinite n equal to 1 un diverges if L is less than 1 and third condition sigma infinite n equal to 1 un test fails if L equal to 1. Now take one statement for implementing this formula. 2 by 3 plus 2 multiplied by 4 over 3 multiplied by 5 plus 2 multiplied 4 multiplied 6 over 3 multiplied 5 multiplied 6 7, then plus 2 multiply 4 multiply 6 multiply 8 over 3 multiply 5 multiply 7 multiply 9 up to. This is given statement. We have to implement Reb's test for testing convergence. You should write here un is equal to 2 into 4 into 6 into 8 up to 2n over 1 into 3 into 5 into 7, that is comes from 2n plus 1, from 2n plus 1 series. When we take n plus 1, that should be equal to 2 into 4 into 6 into 8 up to 2n plus 2 over 1 into 3 into 5 into 7 up to 2n plus 1 plus, when we add 1, it should be 2n plus 3. It will be 2n plus 1 and 2n plus 3. Then we implement limit n is to infinite un over un plus 1 over un, and implement on the right side also limit n is to infinite to n plus 2 over 2n plus 3, and here you can see this will be just a minute. Here we have also write 2n, and when we implement un plus 1 over un, and it will be equal to 1. So here test fails. How? You can see here it's fine. Un plus 1, that is equal to 2n plus 1 n plus 2 over 2n plus 1 2n plus 3, and over un, that is 2n plus 1 over 2n 2n cut with 2n plus 1, this cut with this, and finally you will remainder value you can see 2n plus 2 over 2n plus 3. Now next, just a minute, hold. Now I am going to implement next test, that is logarithmic test. Logarithmic test. In this test, first of all, you should be let sigma infinite n is equal to 1 un be a positive term series such that limit n is to infinite un over n into un over un plus 1, that is equal to L. And there are two conditions that should be implement. First is sigma infinite n is equal to 1 un converges if L greater than 1. Sigma infinite n is equal to 1 un diverges if L is less than 1. In this case, we will not implement third test, that is L is equal to 1, in which we can say test is fails. Now take one more examples related to logarithmic test. For example, x plus 2 raised to power 2 x raised to power 2 over 2 factorial plus 3 raised to power 3 x raised to power 3 over 3 factorial plus 4 raised to power 3 4 raised to power 4 x raised to power 4 over 4 factorial plus, here we will take un. First of all, un n is taken as a 2 and n raised to power n, and here we will take x raised to power n over n factorial. When we take n3, then it will be 3 raised to power 3 x raised to power 3 over 3 factorial. When we take n4, 4 raised to power 4 x raised to power 4 over 4 factorial. When we take 5, then it will be 5 raised to power 5 x raised to power 5 over 5 factorial. It will be continue. And when we take it n plus 1, then it will be n plus 1 whole power n plus 1 into x raised to power n plus 1 over n plus 1 factorial. Now take the limit both sides, n raised to power infinite, and it will be right un plus 1 over un equal to limit n raised to is to infinite, and we will write n plus 1 whole power n plus 1 into x raised to power n plus 1 over n plus 1 factorial, and into n factorial over x raised to power n raised to power n. Now solve this. Limit n raised to power infinite n plus 1 whole power n plus 1 into x raised to power n plus 1 over n plus 1 factorial multiply. I am writing again statement previous so that we can easily solve it. N factorial over x raised to power n raised to power n. Now I am going to solve it. N is to infinite. Take first take the value common value here. N raised to power n x raised to power n common. First take x raised to power n common. N plus 1 whole power n plus 1 into x over n plus 1 n factorial. Here n factorial over n raised to power n x raised to power n. This cut with this cut with this, and you will find this value n plus 1 whole power n plus 1 into x over n plus 1 into n raised to power n. Now you can take common n plus 1 whole power n common, and n plus 1 value will be taken common, and inside it will 1 plus 1 over n whole power n into x over n plus 1 into n raised to power n. Here you also take the common n raised to power n. It will be cut with this value, and you will find 1 plus 1 over n raised to power n into x, and write here limit word also till we will fill limit value. Limit n is to infinite. Now put the value. When you can see this equation is equal to e, so e into x, that is equal to ex, and hence by ratio test given series is converges, because ex is less than 1, that is x is less than 1 by e, and diverges given series is converges and diverges if ex is greater than 1, x is greater than 1 by e. So test here fails if ex is equal to 1, that is x is equal to 1 by e, because un plus 1 over un involves, that is applying logarithmic test un over un plus 1, that is equal to 1 over 1 plus 1 over n whole power n into x, and 4x is equal to 1 by e, that is un over un plus 1 equal to 1 by e into 1 by 1 plus 1 by n whole power n, and when we take log un over un plus 1 equal to log e minus log 1 plus 1 over n whole power n. Log e is equal to 1 minus and n log 1 plus 1 by n, and 1 minus n taken common, and log 1 plus 1 by n's formula is 1 by n plus 1 by minus 2 minus 2 raised to 2 into n square plus 1 by 3n cube. This series is given. So that's why here we will write 1 by 2n minus 1 by 3n square. This series will become, and after taking limit n is to infinite log n log un over un plus 1, that is equal to limit n is to infinite n and 1 by 2 n minus 1 by 3 n square plus up to, that is equal to 1 by 2, that is less than 1. So by logarithmic test we can say series diverges for x is equal to 1 by e. Here x is 1, x less than 1 by e converges, x greater than 1 by e diverges. Thank you. If you